everyone, this problem has been asked in GATE 2014 session 3 and it is of 1 mark. So it was asked in GATE 2014 session 3 and this problem has weightage of 1 mark. So coming to the problem says that a state diagram of a logic gate which exhibits a delay in the output is shown in the figure, where X is the don't care condition and Q is the output representing the state. The logic gate represented by the state diagram is, and the options are X OR, B is OR, C is AND, D is NAND. Before we start to solve the problem, if you want to have a detailed concept regarding this problem, you kindly refer this NPT lecture number 23, a state machine, and the NPTEL course name is Digital Circuits and System by Professor S. Srinivasan, Department of Electrical Engineering, IIT Madras. And I have also shown over here the YouTube link. So before we begin to solve this problem, let us have a definition of a state diagram. So a state diagram is a graphical representation of a dynamic system's behavior over time. It encapsulates the system internal state and its response to external inputs. The state diagrams provide a clear visual understanding of the system, making them invaluable tools for control system analysis. That is very important. So let us solve this problem. So here this state transition diagram is given below. So let us make the truth table for this state diagram. So A and B are the inputs and Q is given over, and let's suppose the next state output is by. So when we are having A both inputs 0 0 and take Q as 0 also. So in that case we can see that 0 where it lies. Yes, here we can see that this will come 0 don't care condition. So from Q is equal to 0 it goes to Q is equal to 1. So output you will get 1 in this condition. Here I want to just mention that this first two denotes input and this denotes output. So we will get output as 1. Now next input we take both 0 and in this condition we take Q as 1. So when Q as 1 and both input having 0 value, then it remains the same state. So it remains at the same state, that means Q will get 1, output you will get 1. Now we take both inputs as A input as 0 and B input as 1 and take Q as 0 state. So where it lies? Yes, here it denotes here Q 0 and don't care condition. You take either 0 or 1, then it moves from Q is equal to 0 to Q is equal to 1, then you will get output as 1. And the next we take input same and take the condition of Q as 1. So in that state it remains at the same position. This denotes 0 and don't care condition, it remains at the same position, so it will be 1. Now taking A as 1 and B as 0 input and the condition Q is equal to 0. In that case it will come in this position, so it changes a state from q is equal to 0 to 1, then you will get output as 1. So you will get this position a and b as 1 and 0. So from q will change its state from 0 to 1, you will get output as 1. And again we take a as 1 and b as 0 and q as 1. So in that case we are taking q is equal to 1. So here it will comes 1 0. The It did not change the state, it remains as it is. So output will be 1. Now we take a and b both inputs as 1 1. So and q as 0. So so this will count into this one and it does not change the state, so output will be 0. And in the next case, we'll take both inputs as 1 and q as 1. So you can see this will come. So both inputs as 1 and q as 1. So it will change the state. So it goes from 1 to 0. So you will get this one. So this is the output for different cases, for different inputs and different initial conditions. So from here we can see that when we are having a and b as 0 0, then you get output 1. And when we are having 0 1, then you will get output 1. And when we are having ab as 1 0, then you will output having also 1. And in only one case, when both inputs having value 1, then you are having output as 0. So from we can say that this is the truth table of NAND gate. From the truth table and a state diagram, from the truth table and a state diagram, we can say that this state diagram represents the logic gate NAND gate. So it represents NAND gate. It represents the NAND gate. So the state diagram representing the NAND logic gate. So the correct answer for this problem is D. That's all. Thank you.